hate math.
Yes, we hate math too. Math should burn and...
Yeah, shh. Squishy Sensei's coming.
Okay, today we are learning about calculus.
Ah.
What is this? What is this? Math is fun. It has feelings. You'll learn the ways of calculus. Let's start with a PowerPoint presentation. Okay, so extreme value theorem. If f of Pikachu is continuous on a closed interval a to b, then f of Pikachu has at least one minimum and one maximum. And to find the minimum and maximum, you have to find the critical points, which is the derivative, and set it equal to 0 or see if it doesn't exist. As you see from this diagram, the maximum and minimums are shown, and the absolute maximum is the highest point. The maximums are the also high points, but not the most highest point, and the minimums are basically the same thing for the lowest point. And the way to think of it, you could see that it could be a mountain or a valley. Yeah, like this picture here.
Cool! Mountains and valleys!
Yep. Okay, let's go on. Okay, let's do a problem. Find the extreme values of y equals 2x squared minus ax plus 9 on the interval 0 to 3 and where they occur. Well, step 1. Let's find y prime. Y prime is basically the derivative, so yeah, this is what you get, 4x minus 8. Okay, step 2, find critical point. Remember that a critical point is where y prime equals 0 or doesn't exist. So you basically set the equation to 0, and you get x equals 2. Step 3, we do the y prime test. Basically, you find where in the domain where y prime is positive and negative. To do that, you plug in values that are close to the value x equals 2 and see if they are negative and positive.
Do we only have to do the sign chart?
No, you have to label it. And by labeling it, you have to label y prime is less than 0 and y prime is greater than 0. And that's pretty important on the AP exam because, hey, they won't recognize a sign chart. So in the sign chart, the 0 here that highlighted in red is where you show what the critical point is a critical point for. The 2 here is where you put in the actual value of the critical point. So step 4, determine if the point is the extreme value and tell which one it is. And this analysis here. So y prime is smaller than 0 on the interval 0 to 2, meaning the left of 2. And y prime is greater than 0 on 2 to 3, or to the right of 2, or x equals 2, and they exist out, and x equals 2 exists. So the function is decreasing on the interval where the slope is negative and increasing on 2 to 3, which is where the slope is positive. And this makes x equals 2 a minimum. And plugging it back into the function, you get y2 equals 1. Okay, step 5. You check the endpoints of the interval for extreme values. This is really important if you have an interval in the first place, because they are considered minimums and maximums too. And so, yeah, we do that whole sign chart analysis thing with these guys sort of thing. And then we find out they're both maximums. And then you plug in the values into the original equation, and you get the points 0 and 9 and 3 and 3. Then your final answer is the absolute minimum, or the minimum that's the most minimum, is 2, 1. Absolute maximum is 0, 9, and a relative maximum, which is not the most extreme value, is 3, 3. So now it's optimization. Yay! It's basically maximizing or minimizing something like area, volume, happiness, sadness, etc. Anyways, so in this example or picture here, Gigi's height is maximized.
Look! Gigi got fatter!
I'm not fat!
Anyways, so we just find out the formula for what you need in terms of one variable, like Totoro here. So let's do another example.
Aww.
Well, we kind of have to. So let's find two numbers whose sum is 20 and whose product is large as possible. First step, we find out what this means. Okay, so we make one variable x, and the other variable must be 20 minus x, because x plus 20 minus x equals 20, which is what the problem says. And to find the product, you basically multiply the two numbers together. Easy math, right? Okay, so now we find a maximum extreme value. Remember, to find a maximum, you find the critical values, and then, which is when f of prime equals 0 or doesn't exist, and you see whether the f of prime is negative or positive. So we do that when we find a derivative, yeah, basically what I just said. And then, doing all that, we say that x equals 10 is a maximum. Solving for the error variable, so it's like 20 minus 10, it turns out also to be 10. So that gives our final answer, 10 and 10.
Wow, that makes sense. 10 times 10 equals 100.
Yeah. Okay, so now to find related rates means to find the rate of something, of a situation, in respect to another aspect of the situation. So using this example, problem, whatever thing here, we basically know that the height of the ladder is 6 feet and that it's sliding away from the wall at 1 foot per minute. And drawing a picture, we see this guy and his ladder fell down. Labeling it, we find that 1 feet per minute is sliding away, and we need to find how much it's sliding down. And by the way, if you draw your pictures this detail, you'll never actually solve the problem in time. Okay, we do this problem here. The length of a rectangle is decreasing at the rate of 2 meters per second, while the width is increasing at the rate of 2 meters per second. So when length equals 12 meters and width equals 5 meters, you need to find the rate of change of the area. We just label it A. So step 1, organize your information into want, know, and relate. Want here is basically your goal. You're trying to find the rate of change, dA over dt.
Why is this O over dt?
It's because the t stands for time, and that's the independent variable. Pretty much everything here is based on time. So, step 2. We find the derivative of both sides in relation to time t, like we just said. And to do that, we use the product rule, and this is what you get. Step 3, you just plug in the numbers. Hey, you already had a chart with organized information. You just plug the info in. And this should be easy. So, yeah, doing all this, you get the answer to be 14. That gives you your final answer. The area is increasing at 14 meters per second. You have to remember units because on the free response on the AP exam, you actually give you credit or points for putting the units in. And yes, Mashimoto, this slide is dedicated to you.
Yay!
One more thing we need to know is concavity. Basically, if the graph curves up or down. This is one way to remember it. Concave down, it's a frown. Concave up, it's a smile.
Oh, that's so easy to remember.
And to find where the points of where the concavity occurs, you just do the second derivative and set it equal to 0. And yeah, that's where you find when the graph changes. If f of Pikachu is a differentiable function over a to b, then at some point the average slope will be f prime of Pikachu. So if the average slope for this interval is this line right here, then at some point on the graph, a point will have the same slope. Yay! So guys, what did you think about math today?
We don't like it.
We love it!
Okay, let's do an example right now. So, we find the extreme values of y equals 2x. Oh, wait, the square is in the wrong place. Math, math, we all love math, it's great. It's fun for everyone there, so many things to learn. There's Algebra 1 and Algebra 2. Mathematics are all for you. Don't forget geometry, trigonometry, as well as calculus too. This is the end.